everyone. Today I'm talking about optics. Did you ever see trees or other objects floating in still water of a lake? Water in the lake is so calm that it reflects visible light almost as clearly as a mirror. Mirror is one of many devices people use to extend their abilities to see. Mirror allows people to see themselves as other people see them, also to see behind their back. Mirror is also used in instruments such as telescopes. Use of light in devices such as these is possible because of optics. Optics is the study of visible light, and waves can be used to extend human vision and do other tasks with this reflection of light. Almost all surfaces reflect some of the light strikes them. The still water of the lake reflects almost the light that strikes it. Reflected light forms an image of nearby objects. The image is a copy of an object that is formed by reflected or reflected light. Whether reflection is regular or diffuse depends on the smoothness of the reflective surface. If the surface is extremely smooth, it like very still water, and the image is formed by reflection is sharp and clear. It's called a regular reflection. The surface is even slightly rough, an image may not form, or if there is an image is blurry or fuzzy, it is called a diffuse reflection. The wave of light are represented by arrow called rays. Rays that strike the surface are referred to as incident rays. Rays that reflect off the surface are known as reflecting rays. In a regular reflection, all the rays reflected in the same direction. It explains why regular reflection forms a clear image in a diffuse reflection. In contrast, the rays are reflected in many different directions. This is why diffuse reflection forms, at best, a blurry image. One thing is true of both regular and diffuse reflection. The angle at which the reflected rays bounce off the surface is equal to the angle which the incident ray strikes the surface. This is a law of reflection, and it applies to the reflection of all light. Angle of reflection always equal to the angle of incidence. Angle of both reflected and incident light are measured into an imaginary line called normal. It is perpendicular at a right angle to the reflected surface. With mirrors, mirrors are usually made of glass, shiny metal backing that reflects all the light and strike it. The mirror may have flat or curved surfaces. The shape of mirror surface determines the type of mirror image the mirror forms. For example, the image may be real or virtual. Real image forms in front of a mirror where reflected light rays actually meet. It is a true image that can be projected on a screen. Virtual image appears to be on the other side of a mirror. Of course, reflected rays don't actually go behind the mirror, so virtual image doesn't really exist, just appears to exist to the human eye and brain. Most mirrors are plane mirrors. Plane mirrors have a flat reflective surface and form only virtual images. The image formed by a plane mirror is also life-size, but something is different about the image compared with the real object in front of the mirror. Left and right are reversed. The mirror image refers to how left and right are reversed the image compared to the real object. Some mirrors have a curved rather than a flat surface. Curved mirrors can be concave or convex. Concave mirror is shaped like the inside of a bowl. This type of mirror forms either real or virtual images, depending on where the object is placed relative to the focus point. The focus point is the point in front of the mirror where the reflected rays intersect. Concave mirrors are used behind the car headlights. They focus the light and make it brighter. They also used in some telescopes and concentrate solar plant. And the other type of curved mirror, convex mirror, shaped like an outside of a bowl. This type of mirror forms only virtual images. The image is always right side up and smaller than the actual object, which makes the object appear further away than it really is. Because of the shape, convex mirror can gather and reflect light from a wide area. This is why they are used as side mirror on cars, give the driver a wider view of the area around the vehicle than plane mirror would. What is refraction of light? Although the speed of light is constant in a vacuum, light travels at different speed in different kind of matter. For example, light travels more slowly in glass than in air. Therefore, when light passes from air to glass, it slows down. If light strikes a sheet of glass straight on or perpendicular to the glass, it slows down by passing straight through. However, if light enters the glass at an angle other than 90 degrees, whenever it refracts, bends. How much light depends when it enters a new medium depends on how much it changes speed. Greater the changing speed, the more light bends. What is lenses? Lenses make use of refraction of light to create images. Lens is a transparent object, typically made of glass, with one or two curved surfaces. More curved surfaces a lens is, the more it refracts light. Like mirrors, the lens may be concave or convex. With concave lenses are thicker at the edges and in the middle. They cause rays of light to diverge, spread apart. The image formed by a concave lens is always vertical and on the same side. The lens as the object. Image is also right side up, smaller than the object. Concave lenses are used in cameras. Focus reduced images inside the camera where they are captured and stored. Convex lenses are thicker in the middle than the edges. They cause rays of light to converge or meet at the point called the focus. Convex lenses form either real or virtual images. It depends on how close an object to a lens relative to the focus. With optical instruments, mirrors and lenses are used in optical instruments to reflect and refract light. Optical instruments include microscopes, telescopes, camera, and lasers. A light optical microscope, also refers to light microscope, is an instrument that uses a lens to make a larger image of objects that are too small for the unaided eye to see. Common type of optical microscope is a compound microscope. Compound microscope has at least two convex lenses, one more objective lenses, and one or more eyepiece lenses. The object lenses are close to the object being viewed, form an enlarged image of the object inside the microscope. Eyepiece lenses are close to the viewer's side, form an enlarged image of the first image. The magnification of the lenses are multiplied together to yield the overall magnification of the microscope. Some optical microscopes can magnify objects more than 1,000 times. Like microscopes, telescopes use convex lenses to make enlarged images. However, a telescope may enlarge image of objects such as distant stars that only appear tiny because they are very far away. There are two basic types of telescope: reflecting telescope and refracting telescope. Camera is an optical instrument, records an image of an object. Image may be recorded on film or it may be detected by an electronic sensor, stores the image digitally. Regardless of how the image is created, a camera forms image the same basic way. Light passes through the lens at the front of the camera and enters the camera through an opening called the aperture. As light passes through the lens, it forms a reduced real image. The image focuses on a film or sensor at the back of the camera. This may be moved back and forth to bring the image into focus. Shutter controls the amount of light that strikes the film or sensor, so it's open longer in dim light to let more in. The driver see a cat chase after laser light. Laser is a device that produces a very focused beam of light, just one wavelength and color. Waves of laser light are synchronized, so crest and troughs of wavelengths line up. Laser light is created in a tube. Electrons and materials such as ruby crystal are stimulated to radiate a photon of light of one wavelength. Each end of the tube is a concave mirror. Photon of light bounce back and forth in the tube of the mirrors. This focuses the light. Mirror at one end of the tube is partly transparent. Constant stream of photon passes through the transparent part from the laser beam. Besides to entertain a cat, laser light have many other uses. This is to scan barcodes, for example, and to use to carry communication signal, optical fiber. Optical fiber are extremely thin glass tube used to guide laser light. Sounds or picture are encoded in pulses of laser light, which is now sent to optical fiber. All the light reflects off the inside of fiber, so none of it escapes. As a result, the signal remains strong. Even over long distances, more than one signal can travel through an optical fiber at the same time. Optical fiber are used to carry telephone, cable TV, and internet signals. I make a summary. Objects that reflect front light may form images. Image is a copy of an object that is formed by reflecting a reflected or refracted light. According to the law of refraction, light is reflected at the same angle that it strikes the reflective surface. Mirrors reflect all the light that strikes them and form images. Plane or flat mirror forms virtual life-size images. Concave mirror forms either enlarged virtual images or reduced real images. Convex mirror forms only reduced virtual images. Refraction or bending of the light occurs when light passes from one medium to another at an angle other than 19 degrees. The speed of light changes the new medium. Greater the changing speed, the more light bends. Lenses are transparent objects, concave surfaces that reflect light and form images. Concave lenses form only reduce virtual images. Convex lens from either enlarged virtual images or real images may be enlarged or reduced. Mirror lenses are used in optical instruments. To reflect or refract light, optical instruments include microscope, telescope, camera, and lasers. That's it. Thank you very much. Haydn G major scale, C major scale, from Krenek, Mozart, Allegro Brilliant, and Haydn Concerto in G major. Yes, that's an arm trot.